Hey everyone, welcome back to my workbench. Oh, I had my second Moderna shot today, vaccination today, so I am really wiped out. However, I did make some progress figuring out this how to interface with the programmer. So what basically I'm doing is creating, you see up here, this is the adapter for the original ZIF 40 socket. So that's an adapter. So what I'm going to be building up is something very similar to that. So this here is plugging into the programmer, which is right over here. This is what a programmer looks like. Okay. This is the little programmer. So this little programmer here, I have this socket here, and they're going to stick in two of these guys here. And these are 20 pins per. Which way should I go? Maybe I'll go this way with it. It doesn't really matter. I'll go this way. I'll do it like they did. If you look up top, you see there's one there, one there. That's the exact same. Those are two rows of header pins on the bottom side, which will mate into little connectors just like this. So this is going to interface with this. And then this guy is going to go on top of here. Actually, it's going to go like this, and I'll have some more header pins over here, so it'll poke in like this. The advantage of this design is if I get it wrong, I can easily flip around this 180 degrees from where it's at now. So it allows me to interface from the cartridge to pins to here. So I got a bit of soldering to do, but it allows me some flexibility. Yeah. So if you look at that bottom board here, the big one underneath is basically this board, and then the guy on top, the upper one, is going to be this board I'm building right here. So usually you would see where that red arrow is at. That's where the ZIF socket, the little sucker, would pop right in the ZIF socket. So ZIF just stands for zero insertion force. There's nothing magical about it. Let's see. I'm going to be able to hit both sides. That'll give me something like that. Or I can turn them like this. Put the, yeah, maybe we'll do that instead. Yeah, I'll do that instead. That'll sit real nice like that. Luckily, all the stuff is all, it's all going to be pins and sockets. See, does that line up okay? Yeah, it lines up just fine. So I got to remove a couple of these. First tonight, I'll solder these sockets in. I'm trying to come up with a good design, and I looked at the programmer itself, which is what that window is, and it's like, oh, I'll just emulate that. It doesn't really help me to buy one much because it's designed to work with the ZIF socket, not the, oh my god, my arm hurts. Okay, designed to work with the ZIF socket, not so much with the cartridge. The one thing I have to be mindful of when I do the final programming, the final wiring for this, is there's a couple pins that don't come out to the, this is the original, this is the actual chip they use on the Tiger learning computer. the TLC uses, I hope the audio isn't messed up for this. The TLC uses this exact chip. It's a US 23C 4000. It's technically a 4001 or whatever. It's on the chip. There's a couple pins that don't come out all the way, and the ones that don't come out are there's a three-state OR expansion. What that means is this chip you can select if it's what size it is, because you can choose it to be 26,144 bit or 512,288 bits. So there's a line there. You basically short out this output, well, not the output enable. There's a chip enable, output enable, but there's the where's that? I forget what it's called. It's on the board itself, on the cartridge. I don't have close by, it's behind me. That allows you to, which allows you to choose the toggle between the total size, the 2 megabits to the 4 megabits. Not megabytes, megabits. It's like those old consoles, like 4 megs of power. Well, it's 4 megabits of power, which is not very big because you got to divide by 8. 4 bits, sorry, 8 bits in a byte. Actually, it's 4 bits in a nibble, 8 bits in the byte, 2 bytes in the word, 2 words in a double word. Where do I want this? There. Yeah, I don't want it all the way over. I want to give myself a little room to work. There we go. Come over one there. Yeah, so you got words and double words. There's some other one above that. I can't remember that. It's been too long. Yeah, I remember when I was back in college, our senior year, you had to build a single board computer from scratch. And that's not just slopping PC components together. You actually had to like wire up the CPU and the memory and write your own operating system and flash it all into EEPROM. We actually use a double EEPROM, which is easier. The second E means electronically erasable instead of just electronic. EEPROM stands for electronically programmable read-only memory. Double EEPROM just adds electronically, which means you can reflash it, which is the modern descendants of that, of course. Flash cards, flash memory, stuff like that. It retains its storage. Like nowadays, like the hard drive on my computer, my main one, is NVMe, which is a type of really fast, really writable double EEPROM. I had a silly project I'd finished over the weekend, and that was my old iMac Ruby. It's a G3 450 megahertz. I swapped out the 5400 RPM drive with excuse me, the 5400 RPM drive with a secure digital card, a U3 secure digital card. It went from a 20 gig to a 64 gig. And I got Ubuntu. Oh my god, that hurts. I got Ubuntu 1604, which is the last version they released for PowerPC on there before they ended the support on it. So I got nice and updated. There is a version of Debian that is new. I'm tempted on that one. But I got it running Mate desktop, and it's on the Secure Digital. It's actually not bad at all. Oh, sorry about the gasps and moans. It's just my arm. My left arm is killing me. Alright, come on. You can do it. There we go. There's 1, 2. Those are out. To borrow some more header pins from work, maybe. A little low. I wish I had a double row. Mine don't. Let's go with the single row. This guy's gonna sit. Let's see. It's gonna sit like this. Oh, no, yeah, it goes to the other side. Durr. Yeah, this side goes here. And then this side goes here, so. I got most of this done tonight, but I don't think I'm going to be finishing it. Oh. I wanted to get this done over the weekend, but I've just been so busy with life in general. Oh, really? I cut it one short. Wow. I am not with it today. Sheesh. Oops. If this doesn't work, maybe I'll get a row double header pins. I might order some. Let's see. This is a little tight. Let's see. See if we can get this to fit. So I turned down the video frame rate to 24 frames a second because at 60 this looks weird, man. I don't like the 60 frames a second. I even turn it off on my TV. I don't like the 60 frame update. I like more of a cinematic look. Does that fit? Let's see. Pins actually fit in there. So I got a blank row there. I got two blanks on the top. Oh, it does. Cool. Alright, so that one's good. Let's see if I've got enough pins to last me here. Solder this up real quick since I'm here. Not worried about ESD because there's no sensitive components here. This allows me to flip things around. I just know that one enable pin does not come out, so I'm gonna have to basically skip over that one. Oops. Wow, I am not with it today. Okay. So the first task I'll do once I get this wired up, I'll try doing just a read back, and then see if I can make any sense of the data that comes out of it, and then I'll do a write back on the rewritable one. Lots of these are just EEPROM. It's only one of the cartridges I have. It's basically a double E version of it, but it uses a battery to keep it refreshed. Okay, so that's this guy here. There, see? Looks a lot like like that guy. Yes, I know not all the pins go through simply because there's not 20 pins on there. There's not 40 pins don't come out to the programmer. Maybe all 40 do. No, I don't think all 40 do. I think it's limited. Running a little low on headers, so I think I'll reuse some here. Doesn't matter if they're not continuous. That one doesn't want to go there. Oh, that's the bumpy part. The bumpy part goes the other way. Okay. So that leaves me 2, which is good because I have 2. This line around here. I see, it's to flip you around. See if you fit better. And you do. There we go. And I got a spare 2 here. Let's go. Let's turn her around. Let's fit. Let's try this one. Oh, come on, hands. Work with me here. This doesn't quite fit. Let's see. Okay. Yeah, still got 1 row. Good. That's fine. And then a day or two, when I feel like warmed over death, I will go and do the final figuring out the wiring. Oh my god, my eyes are not doing good right now. Where's Grandpa's reading glasses at? Back there somewhere. I got 10 more joints to go. So hopefully at the lower frame rate, it's not so big of an upload. That was ridiculous. I'm not doing an action movie here. I don't need 60 frames a second. Oh, I've lost all sense of time. It's really annoying. Okay, so gotcha. All right. There we go. So, like I said, this guy here is just like the upper guy here, and then this board here, the bigger one, actually goes this way, is just like the board you see there. So it all mates together like so. When it mates together, it's actually very similar to that creature up there. A little bit offset, but now it's just a matter of a bunch of wiring. What I'll do is on the lower board, I'm just going to go 1-to-1 the whole thing, and then I'll do the specific wiring for this little hat here. So if I need to change the hat, I can. Alright, that's enough for tonight. I'm beat. Oh. Thanks for watching.